curves. Here we go. There's usually one of these on FRQ. Okay, there's one of your FRQs, guys, stop talking please, is going to be on area, volume. They're going to combine everything in this unit on one question. So it kind of depends on what they want you to do. Sometimes they'll throw in a related rates and put in there, or a limit or whatever, but they'll usually have you do an area, then a volume one way, a volume another way, and then some rando question they'll make you do. So what you do to find an area under this goofball curve, okay, is you take the area, see, I'm switching up the colors, so don't look at these colors, but I'm taking the area above minus the area below. That's what I'm going to do. So to find the area of this like goofy shape, okay, I'm going to do the above function as pink, okay, and then the below function as blue. So things to keep in mind, okay, integrals have not changed, as in, remember, your dx is still like a width. Remember, because like an integral, like if you look at this is the height, this is the width, and you're taking an infinite amount of rectangles. Here we go. Here, I got the limit definition here. So it's very imperative that you understand where these are coming from. A lot of these questions are just pure setup questions. And the setup is what's most challenging, okay? So what you want to do is, if you're reading it left to right, and this one's clearly above, this one's clearly below, you're integrating left to right, right? So like your interval, you're reading this left to right. So you're going to be integrating with respect to x for these, okay? So all of these are going to be with respect to x. When I first learned these, or when I first talk about these, I almost always default to this formula before I start combining them, just because I don't want to make any goofy mistake, Yusuf, okay? So I'm going to integrate from A to B, and because that is horizontally, right, it's because I'm reading this left to right, it's going to be in terms of x. So my upper function, I'm going to find the area under the curve of my pink guy, the one above it, and then I'm going to find the area of my blue guy, the one below it, and then subtract them. Okay. And that's pretty much the gist, except when you look at something like this. So say this goofy shape, like here, if you read it left to right, it's kind of like what's above, you know, because this is like you're hitting itself. This one, it's like this line minus stuff, right? So what we're going to be doing in this class is we're going to do integrate and in terms of y as well. Isn't that fun? So for this one, okay, what I do is I think of the positive x-axis as a positive y-axis. So if you think about twisting this over, okay, we're going to be integrating from C to D, okay, because we're going up and down. So this is going to be dy. So all this stuff is y stuff. And again, this is the formula I usually default to when I'm first doing it. And the function above it, because it's hard to tell like which one's above, below when you're doing y things, is think of turning this where the positive x-axis is now the positive y. So you're going to turn it this way. So your upper bound on this one would be, whoops, why am I using highlighter? This guy. This would be your upper bound, f of y, minus your lower bound. Now, integrating these is any integration technique is fair game. So you might be throwing U sub, it might just be easy like power rule stuff. You might throw an inverse tangent in there, why not? You know, it'll just be like whatever. So any integration technique is fair game. So Honestly, these just take practice on like knowing how to read the graph to figure out one, if it's dy or dx, and then which one's like above, below. Okay. So the best ones are when they give you the graph. Okay. Because a lot of the times they don't. They'll just give you the equation and you just have to like figure it out what they look like. So that's a lot of like knowing what a parabola looks like. They're usually easier graphs, like what a line looks like, that kind of thing. So this one, you try to see which function is like above the other one. So it has to be above every value than the other function. So here, if I look at this one, this line, its y values are above every y value in this function, right? Like it's, the pink is bigger than all of these values the whole time. Yep, because they want the area between the two curves. So they want, yep, so whenever they say, yeah, the between part, you're doing like this. They love the little leaf guy. I call him a leaf because it kind of looks like a leaf. Maybe, I don't know. Okay, so on this question, I'm reading it left to right. Okay. I see that it goes from 0 to mystery thing, maybe. Hopefully it's 5. We'll see. Okay. How do you know for sure? Just figure out their intersection. So this is a thing you will be doing a lot. Okay. So sometimes they give you psycho equations and you're going to use your calculator. So on the calculator portion, they'll give you crazy equations and you're going to have to figure out their intersection. So that's like calc intersect. Graph them both, do calc intersect. We'll do that more tomorrow too. Otherwise, for this one, if it's no calculator, to figure out when they intersect is just figuring out when they're equal to each other. So you're just going to solve like basically 5x equals x squared. Don't do anything goofy like divide out an x. That's silly. Okay, remember you should remember always get 2 answers because they intersect twice, right? So you're going to factor it out. And it was 5. That's cute. Never assume though, because I've seen some evil things. Okay, never assume. It looks like it's 5, but never assume. I'll show you one from a different year. So mean. So what would that be? 5. Do you know how to get the y value? You just plug it in. So you could do 5 times 5 or 5 squared. So 25. Right. Okay, so I'm going to integrate. The pink is always above the blue when I read it left to right. So because I'm reading it left to right, this is going to be an X world question. So to find the area, I'm going to find the area under the pink curve, and then I'm going to find the area under the blue curve, and then I subtract them. So I'm going to go 0 to 5, because those are my x's, right? So 0 to 5 of the pink guy, and what's the pink guy? The line, okay? So 5x, and I'm integrating with respect to x, so it's going to be dx minus integral from 0 to 5 of the blue guy, which is x squared. Dx. Okay. So when I'm first doing this, I almost always start with them separate, especially when it's a little fancy. And then when I actually get in the nitty-gritty of solving it, I usually just combine them. So I'll usually do, just because it's less work, I think, you can combine them as 5x minus x squared dx. Oh, I didn't keep up with the green. That's okay. And then you would integrate it. Nope. There you go. So this is like normal power rule, plugging in your numbers. So ready, go, get the answer. Yep. 125. 6. Okay. All right. All right. So antiderivative, plug in 5. These are totally normal numbers to deal with. Okay. And plug stuff here in. Plug in 5. Okay. All right. So next one. Okay. This one's going to be calculator. Actually, yeah, it is. This will be calculator. Okay. Okay. So, what you're going to do is you're going to have to find the area of the shaded. So, obviously, there's the shaded. Okay. And you want to first see if you're going to do this in terms of x or y. Okay. So, if you're looking at this, reading it left to right, is there a function that is always above the other one? Right? That's how you always have to think about it. Like, are all the points on the curve greater than or like above the other points on the curve? That's how I like to think about it. So, like for this one, you should hopefully, when you read that left to right, like this one, all the values are always above it all the time. Okay? And then all the values, this blue one, like I said, is always below it. Right? All the time. There's not like a switch or anything. It's always like all the time. Don't worry, we'll do one where it's not. Okay? So we're going to be reading this like left to right because that's how I'm reading it, left to right. Okay. So we have weird intersection to x equals 2, right? So we're going to integrate in terms of x. Okay? So we know it's going to go to 2, but we don't know this rando point, like that little negative guy, okay? So what you're going to do is you're going to figure this out on your calculator, okay? So essentially, you're going to you're going to throw this guy in your y sub 1, okay? And you're figuring out when it equals your other guy, 1 plus x. And that's going to be in your y sub 2. So this is like mathematically what you're doing when you're doing this calc intersect. You're going to put this in y1, this in y2, and then you're going to hit second calc intersect. So you're going to go second calc intersect, and it'll look like the curve, and then it'll give you an ugly number. Okay, and please don't ever be the kid that says negative 0.2, okay, because in this class you're always at least 4 decimal places. Okay, so I don't know if we need, just do it quick, but you're just throwing it. I was teaching sines and cosines in geometry. Remember that? Opposite over adjacent. Stuff, hey? Okay, so you're going to do square root x plus 2. And then, I don't want to erase my derivatives. So then you're going to do the other one. 1 divided by 1 plus x close graph. Oh, shoot. Okay. And then you're going to hit second calc and do intersect. And then you just kind of do something close to it. And I'll tell you the answer. And I always truncate. So negative 0.2451. Okay. Yes, right.
Are you changing the problem from using to calculate just intersect?
No, I'm not done yet. This is just part of the problem.
Oh, okay.
Yeah, we're not done yet. Because we still have to find the area. So now to find the area, you need to take the integral from this negative 0.2451 number to 2. And you're going to do the upper bound minus the lower bound. Oops, negative. The reason this is calculator is because of the intersection, not because that's hard to integrate. Okay? The integration on that is not hard. The intersection is what's hard. Okay? So maybe I'll just kind of, I think I'm going to show you the antiderivative for that just to be sure. But I'm going to put these together because then it's less typing. So it'd be the square root of x plus 2 minus 1 over x plus 1, or 1 plus x. I'll do 1 plus x so we don't get crazy. That's all dx. Okay, so you could do a u sub for both, but remember with like when we did long division, you know how it's like 1 divided by all of that? You could technically kind of think about it in your head, because if you do a u sub for this, your du is just dx. Same for this one. So what I do is you treat that as like x to the half power. So the antiderivative of this would be x plus 2 increase the power, divide by the new one. You treat it as x to the half, basically, right? And then here I treat it as 1 over x. So that's going to be natural log, but it's not too complicated under there, so you're just going to do natural log 1 plus x. So again, this was calculator because of the intersection piece, but the antiderivative shouldn't be difficult anymore. Okay? Yeah?
You don't have chain rule in x plus 2, right?
You don't need to because, well, you are, but it's a 1. So,
What if it's a 2? What would you do?
well, if you're doing, well, think about if you did the derivative of this. Right? If you took the derivative of this, this would turn to 1, and this would be a half, and then times 1. So you get this back.
So if you do the antiderivative, you just divide by it. So if it was like 2x, you have to divide by 2. Or would you?
Oh, if it was 2x plus 2, then I would have a half with it. Yeah. So if this was like 3x plus 2, it would be a 1/3. Yeah. Yep. All right. So then remember, as far as typing that's concerned, do you guys remember? Well, you kind of have to know how to do it anyway. But to do this, you go math 9, and you would do negative 0.2451 to 2, and then you would type in your values. Trick is use your shoot. I can't remember if I put it under y4. Was it 4? Did I put it under? I don't remember. 4. There you go. Was that an answer? Yeah. Okay. Right. Yeah. Math 9. Okay. Questions? All right. Now this guy. If you look at this one, you're given 2 curves. Okay. Now, if you look at one curve, so say I looked at this one because this one looks above it. Do you see how if I look at just one curve, it's not above all the values of the other one? You know what I'm saying? Like, well, first of all, it's like above itself. Do you know what I'm saying? Like if you're going left to right, it's like above itself. And then this one, it's like, is that, which one's above? You know, like they're kind of just crossing each other, right? Another hint for this one is look at the equations they give you, right? They're both in terms of y. So like, it's kind of like a cheat way to tell that we're going to be integrating in terms of y. Because if you picture, so like, picture your positive x-axis as your positive y. So I kind of like if you turned your head, that's what it looks like, you know? So if you turned your if you turned this, counterclockwise 90, okay? You can tell a little easier that this one now is always above it, right? Doesn't that curve look above the whole curve, this whole other one, the whole time? Okay, so this one is going to be integrating in terms of y, because what you're integrating from is from this intersection point to this intersection point. Okay, you're integrating like vertically, so up and down, right? So your upper bound, again, like turn your head, right, to see which one's going to be the one like on top, whatever. So that's why I just took a picture and twisted it on the document here. This is your upper bound if we're integrating in terms of y, and then this would be your lower. Yeah. Yep. I always turn the positive x into a positive y. So I always rotate it that way. Yeah. Yep. So now we're in y world. Okay. So everything's got to be in y stuff. So I'm going to integrate, but I have to integrate in terms of y things. Okay. This one, I'm just going to tell you, just trust me, it's at the origin. It's for sure. Okay. That one's at the origin. So I know we're going to integrate from 0, but then your bounds have to be in terms of y. It has to be up and down. So you don't want to use the -3 because that's the x. You got to use only y stuff. So it's got to be 3. Okay. And your upper graph is, wait, it's y stuff. That's exactly what I want. dy minus, and a lot of you, as you get used to this, you might not have to separate it like I'm doing it. I just do because I know it's always right. And I'm a little crazy about that, so y squared minus 4y. So I usually do this and then do dy, okay? Then as far as solving it, this one is to your advantage to put them together because you can actually like combine like terms, you know what I mean? Instead of dealing with all that, there's going to be a lot of fraction work on that. especially with cubing. Ugh, I don't want to do this. It'll be fine. Positive attitude, right? Because if you subtract those, what would that be? 6y? Oops. 6y minus 2y squared. Is that what I got? If you combine them, right? Because I did 2y minus negative 4y, and then negative y squared minus y squared. So I got 2. So then, doing an antiderivative, I'm losing room. No. Would be 3y squared minus 2/3 y cubed from 0 to 3. And you plug in your junk. So you're going to go 3 squared minus 2/3, 3 cubed, and then minus 0. Use some like little strategy here, especially with the cubing. You can cross reduce one of the 3's. You know what I mean? So you can just do 3 and then make it 3 squared. You know? So that'd just be 18. That second one. And then so it'd be what? 27 minus 18. So 9. I fit it in. That worked, right? Maybe?
You don't need like any sort of unit manuals.
Nope. No unit. Yeah.
So if
Okay.
you're looking at the sideways picture,
Yeah.
where are those green lines? Where are our vowels?
Oh, here to here.
Oh,
Yeah. I usually do the turning of my head to see which one's above, below, mostly.
and then you go back to like the normal picture?
Yep. Yep.
So you just use that to determine what the upper and
Exactly. Yep. Yep. Okay, this is the worst kind. Yeah.
Does it matter which way you turn it?
Yes. Positive x-axis, positive y. Okay. All right, so these are the fun ones. Sarcasm. You just have to know what they look like. Yay. Okay. So hopefully the line's not the issue. The cubic one, you know, that's like it's got like a max and a min. It's like curvy like that. So they want it to the right of the y-axis. Okay. That's like right. Okay. Let's do the line. That makes me feel better. Okay, let's do the line. Okay, here's the line. Y equals 3x. You guys knew that was a line, right? Okay, thank you. Thank you. Okay, now this cubey guy, right? So, I mean, a couple things. I mean, you should know what cubic looks like. You know, cubics looks like these. You know, something like that. They have a max and a min. Honestly, you just need to know if it's above or below that. So the parent graph for cubic, like x cubed, is like this guy. Oh boy, that was bad. Like this guy, right? That's x cubed. So minus x is just going to adjust. I mean, another thing you can think about is this, where your zeros are going to be. You can kind of think of it that way. So at 0 is where this curve's going to be. I know I'm going to have another 0 at 1 and negative 1, but I'm only dealing with the right of the y-axis. So I'm guessing it's, I don't know, we can put 1 over there. Because I'm just trying to get a vibe for the graph. Because honestly, I don't need to know exactly what this thing looks like. All I care about is what is above and what is below, right? So if you have an idea of what the parent graph looks like, if you get real desperate, just plug in like a half, or plug in 2. I mean, we're gonna have to figure out their intersection point, so why don't we do that right away? That might help me a little bit. Because I have to figure out where these intersect. So I have to do 3x equals x cubed minus x. Oh gosh, I'm getting nervous on this one. Because what do you get? 0? Okay, this won't be bad. Just freaked out for a sec. Right? Scooch that over. We get factor. So it's going to intersect at 0, thank you, 2, and, well, negative 2 is lame. Because I don't want, it's the right of the y-axis. So I don't care about that one. Like, cool, they intersect there, but don't really care about it. So I know it's going to intersect at 2. So at 2, comma, now to figure out the y value, I mean, you don't actually technically need to with this one, is just plug it in. I would plug it into that guy. That one's easier. Or you could plug it in there. Either one. But your y value would be 2 comma 6. So they're going to intersect at 0 and 2 comma 6. And then knowing your idea as a parent graph, you know it's going to intersect. It's going to have a 0 at 1. You know what I mean? Like, you can kind of get a vibe for it. Plug in a half. See if it's going to be lower than 1.5. You know what I mean? To get an idea. So, I mean, long story short, this is what that part of the graph is going to look like. Okay? But what I'm saying is like, these are kind of the different strategies I use to kind of figure out what it does look like. So, like, maybe, like, again, plug in 0.5. That's 1.5, plug in 0.5 there. What is that, 1/8 minus a half, you know? So it's going to be negative. So you can get an idea of what the graph's going to look like. But then now we need to find the area under the thing. So, let's see, can I do this in terms of x? Yes, I can. Could I do it in terms of y? No, you can't. Could you do it in terms of y? Turn it, okay? This is the part that would give you issues, okay? If you did it in terms of y, it wouldn't work because you'd have a blue over a blue, what I'm saying. So this one has to be in terms of x because this pink one is always, all the values on that line is always more than all the values on the blue line. So, to find the area, you're going to integrate from 0 to, what did we say it was? 2? We're reading it left to right. And if you want, you can combine them right away. But you're going to take the area under 3x minus the area under parentheses x cubed minus x. So you could put them together right away if you want, or start with them separate. And then you integrate it. Okay. So I'm going to put these together. Oh, that's embarrassing. Don't look at that. 4. Didn't distribute the negative. Oh, little tricks, little mathy tricks. 2 times 2 squared, I don't think that's an issue. 1/4 times 2 to the 4th. And then minus 0, because that's not going to happen, right? But this one, this is 2 times 2, right? So 2 times 2, and there's 2 2's on the numerator, you can cross reduce them. So that's just 4 for that first term. Do you know what I'm saying? Because you could think of it as this, right? That idea? So what would that be? 8 minus 4. That's your answer. So we did mostly in terms of X today. So you can do most of those in the notes. We're going to do more Y's tomorrow. So you could do a decent amount on the notes, or at least know what the graphs look like.